IGCSE Mathematics Chapter 3, topic is calculation and ordering. Ordering is arrangement. It's just arrangement of numbers, okay? Now let's take a look at the first part of ordering. Now the following symbols have a specific meaning in mathematics. For example, when we write equal to, when we say equal to, we are very familiar with this, right? This one means equal to. Then when we say not equal to, this one means not equal to, right? When we cross it like this, it becomes not equal to. When we cross it, it becomes not equal to. This one means greater than. This one, this sign means greater than. And that means the one when you hold your right arm, if you bend your right arm, that's a sign of greater than. Lesser than is when you do your left arm. When you bend your left arm, it gives you the sign of lesser than. Okay? Then for lesser than or equal to, you get this one. Left arm, then you draw one below it. This is lesser than or equal to. Then for greater than or equal to, you do your right arm and you put this one, you put order it and order it. So these are symbols we need to know in equating two things, two quantities, in trying to describe two quantities or compare two quantities. So this topic has to do with ordering and comparison also. So what this means is that, for example, if I say x is greater than or equal to 3, meaning x is either equivalent to 3 or more than 3. So when you say x is greater than or equal to 3, what you're saying is that x equal to like 3, it means x equal to like numbers like 3, 4, because you say greater than or equal to 3, meaning starting from 3. 3 is inclusive, meaning numbers like 3, 4, 5, any number greater than 3, but starting from 3, because 3 is inclusive. So when you say x is greater than 3, greater than or equal to 3, meaning 3 is part of it. But if we say x is greater than 3, if we just say x is greater than 3, the game will change. Okay, if we say x is greater than 3, it will be a different ball game. Okay, if we say x is greater than 3, it means number from 4, for example, like 4, 5, 6, and so on and so forth. But when you say x is greater than or equal to 3, meaning 3 is inclusive. Is that okay? So sometimes it includes decimal. It could be 3.5, 4, 4.5, 4.2, 4. Any number greater than 3 is acceptable in this regard. Okay? So when we say x is greater than or equal to 3, in another way, if you say x is greater than or equal to 3, another way of doing it or saying it is that you're saying 3 is lesser than or equal to x. If you say x is greater than, meaning x, whatever x this variable is greater than or equal to 3. So in another way, you can say 3 is lesser or equal to x. 3 is lesser or equal to x. Meaning x is a variable that has numbers that are greater or equal to 3. Okay? So it means, this and this, they mean the same thing. So if we write x is greater than or equal to 3, it can as well be 3 is lesser than or equal. For example, if you say Yakub, if you say Yakub is greater than Joseph, okay, let me use only greater than. Is greater than Joseph, for example, is greater than Joseph. What it means, or is older than Joseph, let's use older. Let's not use greater than that. But we know that older means greater, for example. It's just an example. If you say Yakub is greater than Joseph, or older than Joseph, you can as well say Joseph is younger than Yakub. Joseph is younger than Yakub. You know what that means, right? If you say A is bigger than B, it means B is less than A, right? It's the same thing. So that's what this one means. So when you say x is greater than or equal to 3, it means 3 is lesser than or equal to x. Okay, now let's move on quickly. So all of this can be represented in number line. They can be represented in number line. So we can say, for example, if you say x is less than 5, if you say x is less than 5, okay, it means 5 is greater than x. Because you say x is less than 5. X is variable numbers that are smaller than 5. What it means is that 5 is a number that is obviously bigger than x. It means 5 is greater than x. It's the same thing. So x is less than 5, 5 is greater than x. Now these things can be shown in number line, for example. In a number line, if we draw a number line, for example, let's say we have 1, let's say we have, let's say this is our number line. We have 0 here, 0, 1, 2, 3, 4, 5. Okay, let's say this is our number line. Okay, this is our number line, and this is -1, for example. Here's -1, -2. Okay, integers. Integers can be whole integers are positive and negative numbers. Now, if we say x, let's start with the first one. We say x is less than 5. If it's only lesser than, when we draw this, we just put a circle. We don't shade the circle. We just put a circle on top of 5. Let's say we're doing this. X is less than 5. Less than, it means you just go to 5. You draw a circle. If it's only less than, you don't shade it. Then less than, it has to go this way if it's less than. And you put x anywhere here. You put x here. So what this one means, we are saying x is less than 5. But what if I want to do for this inequality? I would say x is lesser than or equal to 5. Okay, when we say x is lesser than or equal to 5. Or x is less than or equal to 3. Let's use another one. Let's say, for example, I have 1 here, I have 2 here, I have 3 here, I have 4 here. Okay, let's say we have 0 here, and we have -1 here. Okay, let's say this is our inequality, our number line. This is our number line, and we have 5 here. Now here, we want to deal with this inequality which says x is lesser than or equal to 3. Lesser than or equal to 3. How do you show it in a number line? This inequality, how do we show it in a number line? We say x is lesser than or equal to 3. So you go to, you can write x anywhere here. You put your x here, okay? You put your x here. Then you simply say that you go to 3, lesser than or equal to. Now this is the difference between the first one and the second one, greater than or equal to. So since this is x is lesser than or equal to 3, you have to shade this circle. So for lesser than or equal to or greater than or equal to, you have to shade this circle. Now if it's lesser than, we go to the left. We go to the left, we draw it to the left so that the arrow will be the arrow of lesser than. You see the arrow of lesser than is the left arm. Is that of the left arm. So this have to show if it's lesser than or equal to, you must shade here. You see this one, when we say x was lesser than 5, only lesser than, we don't shade. We just draw this, and we face it to the left. Now let's give example for greater than. Let's give example for greater than. Okay, if we have greater than, let's say for example we have x is greater than 7. Let's say we have this as one example for our inequality. X is greater than 7. Let's say another example we have is greater than or equal to. Example 2 for question number 2. Example 2a. Okay, let's say the first one is 2a, this one. The one we did just now was question 1a and 1b. Now this one, let's say is 2a and 2b. Now we say here x is greater than or equal to, maybe let's say 9. Greater than or equal to 9. Okay, so if you have this, they ask you to show it in a number line. What you do, you draw your number line for the first one, which is 7. It doesn't necessarily mean you have to start from 0. You can start from 5, 6, 7. Number close to 7, within 7. 5, 6, 7, 8, you do it here. 5, 6, 7, 8, you just put them there. As long as 7 is within this range, okay, you just put this number. It doesn't mean I have to go and start from 0, 1, 2, 3, 4. Okay, then the next thing is to greater than. The first question say x is greater than 7. So I put my x here. Okay. Then let's use a different thing to show, a different color to show this. Now we go to 7. We always go to the number. Okay. You go to 7. 6 is greater. You draw the circle. 6 is only greater than. You draw only circle. You don't shade it. It's only greater than. You don't shade it. So you move to the right. Why are we going to move to the right? Because it's greater than is that of the right arm. So since it's greater than, you move to the right side. Because it's greater than, you move to the right, and you draw your arrow. You draw your arrow. Okay? So this is x is greater than 7. Only x is greater than 7. Okay? Now the B part, this is A, 2A, question 2A. Now let's say we're dealing with question 2B. How do we do that? If you say question 2B, you do the same thing. You draw your inequality. You draw your inequality. Quickly, let's draw our inequality. We draw our inequality. We say the numbers is 9, within 9. So you can start from 7, 8, 9, 10. Okay, you can have 7, 8. So you just do number within the number they've asked you. Okay, 7, 8, 9, 10. You see? So you can stop here. So the next thing, you put your x here. Put your x here, somewhere here. And then you go to the number they mentioned, 9. S is greater than or equal to 9, this number. S is greater than or equal to 9, so you go to your 9. Okay, let's change the color to something conspicuous. Okay, so we go here. So you go to 9. You say x is greater than or equal to 9, greater than or equal to. So you are not only going to draw a small circle on top of it, you're also going to shade the circle. Because greater than or equal to means you should shade the circle. So we go to shade this circle. Okay, we go to shade this circle. And then, because it's greater than, we go to the right side. And then we put the arrow. We put the arrow. That's it. So you've shown this in inequality. You've shown this in inequality. Now the top part of the example, question number 3, I want to show before we end, or before we move to another part of this question, is when they give you double inequality. When they give you double inequality. For example, let's take an example from here. He said the maximum number of players from one football team allowed on the pitch at any one time is 11 players. You know, in football, the maximum player is 11 players, right? Is 11 players. Now, if they say represent this information as inequality, the maximum, okay, maximum player, meaning, let's say P is for player, right? Let's use P for players. Okay, let's use P for players. So we say, first of all, you write down the inequality before you draw the number line. So you say P must be, the maximum is 11, must be lesser. You know, it can be lesser than 11, because if you get a red card, the number of players will reduce. So you say P must be lesser than or equal to 11. That's the inequality to represent this. So when you hear maximum, it means lesser than or equal to. The word maximum means lesser than. If they say at least, means greater than or equal to. Or minimum. Minimum means greater than or equal to. Maximum, please take note. Maximum means lesser than or equal to. Maximum means lesser than or equal to. At least or minimum. Okay, minimum, permit me to write just min, M-I-N. Okay, minimum means what? It means greater than or equal to. This one represents greater than or equal to. Or at least, if you hear the word at least, it also means minimum. Okay, so now let's go to this one. It says represent this one in a number line. We already know how to do this type of number line, right? So if we draw our number line, if we put this in our number line, since we have 11, so I can put 11 here, 12 here, you know, just a number above it, a number below it is even enough. So you put 10 here. If you like, you write 9. If you like, you stop at 10 here, it's okay. So you go to your 11, you go to your 11, you go to your 11, then you show. You say it's lesser than or equal to, so I draw here. I have to shade this place. I have to shade because it's lesser than or equal to 11. Then I go to the left. That's it. You've represented this in a number line. That's the first part of the question. You say, show it as an inequality. We've done that. You say, show it on a number line. We've done that, right? Now, you say the other part, which is the B. This is A Roman figure 1. This A Roman figure 1 and A Roman figure 2. The number line is A Roman figure 2. Now, the B part of the question says, the B part of question 3 says, okay, you say, let the number of players be represented. Okay, this one is an explanation of it. Now, the second part, question number 4. Okay, this is question number 4 actually. Now, question number 4 says the maximum number of players from one football team allowed on the pitch at any one time is 11. Yeah, which we know. The minimum allowed is 7 players. The minimum. Represent this information as an inequality. So 4a is to show it as an inequality. There are, in a football game, the maximum player is 11 and the minimum that is allowed is 7, meaning you cannot give red card to more than 4 players in one match. Okay, you cannot give, so you give red card, remain 10 for that team. You give, if they commit offense, you get a red card. It becomes remaining 9 players. You give red card, remaining 8 players. Give red card, remaining 7. You can no longer give another red card because the minimum number of players that can be in that football pitch is 7. The minimum that can be there is 7. So if they say represent this in inequality. So you say P, let's say P is the number of players, or N, we can use N as the number of players. Okay, we use N as the number of players. Okay, we say N is lesser than or equal to 11, meaning they can be 11 player or less than 11 player, and greater than, the greater than or equal to 7. So this is the inequality. This is the inequality that you should write. Now, why is this one like this? First of all, when we are reading inequality, we read to the right first. Okay, you can pause this video and watch our inequality mathematics, okay, in waidusmacademy. Like, share, and subscribe, and watch our inequality video. You see how we have explained inequality. Okay, so we say N is lesser than or equal to 11 and greater than or equal to 7. You read to the right first before you read to the left if you have double inequality. When you read to the right first, you read before you read to, you can see, you first of all start by saying N is lesser than or equal to 11 and greater than 7. But you'll be wondering, why is it, this is a sign of lesser than, why we say it's greater than 7? Remember I told you at the beginning, I say if you write 7 is lesser than, if you say 7 is lesser than or equal to N, if you say 7 is lesser than or equal to N, remember we say it means N is greater than or equal to 7. Is greater than or equal to 7. If you say 7 is less than N, it makes sense, right? If you say 7 is less than something, it means that thing is greater than 7. So that's why we read this one like that. So you'll be wondering, why do we say N is lesser than or equal to 11 and the same N is greater than 7? Because even if it's written like this, it is N that is greater than 7. 7 is less than N. N is greater than 7. Okay, I hope that is clear. Now show this information. The B part of the question say we should show this information in a number line. Show this information in a number line. So to show this information in a number line is for us to draw a number line. So we draw this number line. So we have 7, we have 8, we have 9, we have 10, we have 11, we have 12. Okay, we're not going to use 12, we're just putting it in our directed numbers, okay? And 6, you can put 6 here, just a number before the real deal. Now, the inequality says, now let's change the color so it'll be clear when you see the number line. So we say, N, you put your N here, remember that, you put your N here. We say N is lesser than or equal to 7. So for double inequality, this is what we do. We don't put arrow, this is what we do. It's lesser than or equal to. Since it's lesser than or equal to, we have to shade it. You say N is lesser than or equal to 7. So you shade this place, you shade it, and then you go to the other side. N is lesser than or equal to 7 and is greater than or equal to 7. N is lesser than or equal to 11 and greater than or equal to 7. So when you reach 7, you also draw the inequality. You bring it to 7. This one, because also greater than or equal to, then you have to shade this place. You have to shade this place. So we shade both of them. But what if the inequality is like this? What if the inequality, because this is what they will be testing you on. So for double inequality, you're going to be having both sides like this. You not put arrow. No need to put the direction of the arrow for double inequality. What if I say, let's say we say y is lesser than or equal to -1, is lesser than or equal to -1, show it in a number line, and is greater than or equal to, only greater than -4. Okay, greater than -4. Question number 5, show this in a number line. Okay, so today we are learning how to show inequality in a number line in ordering. Okay, so we draw this inequality. Let's show this inequality. So we draw this in a number line. Okay, we have minus 1. We can start from minus 1 is the bigger number. Remember, you have 0 here. You have minus 2 here. You have minus 3 here. You have minus 3 here. You have minus 4 here. Okay, you have minus 5 here. Okay, so if you have this, if you've shown this, now the question says that we should show that y is lesser than, so you put your y here. You always put your y somewhere here. Okay, whatever they give you. If it's n, you put n here. If it's x, you put x here. So you say it's lesser than equal to -1. So you go to -1. You draw the circle on top. Okay, and you shade it. You shade it because it's lesser than equal to, and then you go to -4. You draw for -4. This one we're not going to shade. Why? Because you say y is lesser than equal to -1 but greater than 4. It's not greater than equal to, so it's only greater than 4. So you don't shade this one. Okay, so that's this one they did here. If you look at this is what they did here. So there are many examples. Sorry, not this one. This one. This is what they did here. If you look at this, from -1 to -4. This one was not shaded. This one was shaded. Okay, so that's what it is. Now let's move to the next page. Beside, we also can be given in ordinary. You know, we are doing ordinary. You say, right, before we do that, before we look at that, let's see if there's, okay. Now, since we are doing ordinary, you can be given numbers and you are asked to arrange them. For example, you say, write the following decimal in order of magnitude, starting with the smallest. You'll be given different decimal and we'll be asked to start with the smallest, right? So we're going to start with the smallest. We have 6.0, 0.6, 0.66, 0.606, 0.06, 6.6, 6.6. So the smallest is this one. So we put number on top. Okay, this is the smallest, number 1. So since they say start with the smallest, this is smallest. So after 0.06, let's look for 0.60, 0.6. Okay, this one is number 2, right? This one is number 2, smallest, 0.6. After 0.6, we have 0, because 0.6 means 0.60. We have, the next one is 0.606. This is number 3. Number 3. After 0.606, we have 0.66. This is number 4. After that, I think all the 0 points, they're gone, right? So we have 6 points. Let's look for 6.0, 6.6, 6.6. So the next one is 6.0, right? This is number 5, the 5th smallest. Then after that, we have 6.606. 6.606. No, this one, 6.60. You know, this is 6.60. This is 6.606. So this one is bigger than this one, because this one is 6.60. It ends there. But this 6.606, because you can approximate this one, it will be 6.61. So this one is number 6, and then this one is number 7. So if you arrange, now we're going to write them from the smallest. The smallest one, number 1, is 0.06. Number 1 is 0.06. That's the smallest number. So when you are arranging, our number 2 is 0.6. So you can put comma, and then we put 0.6. 0.6 as the second to the smallest. Okay. Then the next one, number 3, and number 3 is 0.606. 0.606. That's the next smallest number. Okay. Then the next one is number 4, 0.66. 0.66. That's the next two smallest. Next two smallest. 0.66. Then number 5 is 6.0. So all the 0 points have finished. We now have 6.0. 6.0. Okay, you have to be careful, because you're not careful, you're going to make mistake. And then number 6 is 6.6. Now you see 6.6, what it means is actually 6.60. Okay, if you don't know, you just mix it up. Then the last one is 6.606. 6.606. 6.606. Sorry. 6.606. So this becomes, so this is how to arrange numbers. Now, this is numbers that are in decimal. What if the numbers are in fractions? Say, write the following fraction in order of magnitude starting with the largest. So you got to find which one is the biggest. So this one, sometimes we even change that to decimal so that we can know. Okay, it's easier to know numbers. Like 1 over 2 is very big, but it's not as big as 4 over 5. 4 over 5 is 0.8. So this 4 over 5 is 0.8. So most of the time you turn them to decimal so that you can easily know which fraction is a bigger fraction. Okay, this is 0.8, this is 0.5, 1 over 2 is 0.5. 0.5 is same as 0.50, okay, don't get confused. It's like 0.50, okay, 0.50, okay. This 1 over 3 is 0.33, 0.33, like 33, 33%, 0.33. So when you change that to decimal, it's easy for you to know which one is a bigger one. Now, 7 over 80, what do we get? 7 over 80, what do we get? 0.3, we get 0.388, okay, we can say 0.39. Let's just say 0.39. 0.39. Now what of 2 over 19? 2 over 19 we get 0.11. Which is 0.105, because I'm approximating to 2 decimal places. 0.11. What we jump 1. What about 6 over 13? 6 over 13 we get 0.46. Approximately to 2 decimal places. We are approximating to 2 decimal places. 0.46. Okay, so now which one, they say we should start with the largest. So which one is the largest fraction? The one with the highest decimal, 0.8. 0.8 is bigger than 0.1 because 0.8 means 0.80, okay, like 0.80, okay. Is larger than this 0.39, 0.39, this 0.11, this 0.46. Although after decimal you don't say 11, you just say 0.11. Any digit after decimal you just call it one by one, okay, in mathematics. Okay, you don't say 0.50, just 0.5. You don't say 0.33, you say 0.33. Okay, so that's how we read numbers. Okay, now the biggest fraction is what? 4 over 5. So you write as the largest fraction. So you say this is number 1. Which one is the next to the largest? After 0.880 is 0.50, right? So this is number 2. So you put here number 2. Here's number 2. Which one is less to that? 0.46, right? So this is number 3. These are number 3. After 0.46, I think we have 0.39, which is 7 over 80. This is number 4 in the order of largest to smallest. And then after 0.39, what do we have next? 0.33. These are number 5 in arranging them from largest to smallest. After that, after that, I think it's only remaining this one, right? So this becomes our number 6 in order of arrangement. So if you are writing them in fraction, the largest is 4 over 5. So you write here 4 over 5. Okay, so you always break them into decimal if you want easy flow. Okay, except you are very mathematically inclined, then you're able to tell which one is larger. But for simplicity, always break them into 2 decimal places, and then you'll be able to tell. Then the second to largest is 1 over 2. You write the fraction 1 over 2. You write the fraction 1 over 2. You go into the next one, which one? Number 3, 6 over 13. We write the fraction 6 over 13. Right? Write the fraction 6 over 13 as the next to the largest one. And then we go to the next one, number 4, 7 over 18, right? 7 over 18. So we say 7 over 18 as our next fraction in the order of largest to smallest. 7/18, right? Okay. Then after that, after our 7/18, the next one is 1/3. So you write 1/3 as our next one in the order of largest to smallest. After 1/3, the last one is 2/19. The last one is 2/19. So this how you arrange it. No, in decimal, we've done the first one in decimal. The second one we're doing fraction. So we hope with this 2/19, we hope these two examples are sufficient for you to be able to do ordering and arrangement of numbers. Okay, now but another thing in the exam, if the examiner wants to catch up with you in IGCSE, they may give different units. So let's try one example or two examples that are of different units. Okay, before we go to order of operation. Let's try one or two examples that are of different units before you go to order of operation. Is that okay? Now you see this number is 2 meters 60 centimeters. 2 meters 60 centimeters. So 2 meters, so we have to convert all of them to the same unit. Is either you leave everything in centimeter, or everything in meter, or everything in millimeter. So it's up to you as a student. Okay, it's up to you. Okay, I think this is different from this, right? These are two. Okay, so it's up to the students. Let's change everything to centimeter. 2 meters is times 100. If you want to change meter to centimeter, multiply by 100. 2 meters is 200. So you write 200. Is it right the following length in order of magnitude, starting with the smallest? So we're going to start with the smallest. But let's write them out first before we arrange them. So this is 200 centimeter. We are changing meter, everything, all, because you have to convert all to the same unit. So we are changing to centimeter. Since we are changing to centimeter, 2 meter becomes 200 centimeter. 60 centimeter, you just write it like that because it's already in centimeter. Anyone that is already in centimeter, you write it like that. 80 millimeter, 800 millimeter, you want to change to centimeter, you divide by 10. You want to change to centimeter, divide by 10, it becomes 80 centimeter. Become 80 centimeter. Okay? It becomes 80 centimeter. Now 180 centimeter is already in centimeter, so you write it like that. It's already in centimeter, you write it like that. 180 centimeter. Right? We write it like that. 180 centimeter. I think we shall be writing underneath it. This one you want to change to centimeter, you multiply, is in meter. You multiply by 100. If you multiply by 100, you move this decimal to the front twice. It becomes 75 centimeter. This one becomes 75 centimeter. All are in centimeter now. Now you can tell which one, they are all in the same unit. So which one is the biggest one of them all? Of course, it's 200 centimeter, which represents 2 meters. So you can simply say, right? Are they together? Separate. It says, okay, starting with the smallest. Sorry. They did say we should start with the largest.